In the preceding video, we showed you a way to use a dictionary to summarize word counts. Now, when you're doing things like that, which are kind of common types of tasks, it's often the case that Python already has a library class that can help you with that task. Summarizing word counts is a common technique for text analysis, and it turns out that there is a type in the collections module, which is part of the Python standard library, that can help us perform that task easily. So far we've looked at a number of different built-in collections. We looked at lists and tuples and now dictionaries, and soon we're going to look at sets as well. But there are other types of collections out there, and this particular module actually has a bunch of additional collection types that you can use in your Python code. One of which is this counter class, and it's a type of dictionary that knows how to, as they say, count hashable objects. Hashable objects are immutable objects that you can use as the keys in a dictionary, or that you can use as the elements in a set, where the set elements must be unique. So anything hashable, which would be things like strings and the numeric values like integers and floating point numbers, typically they're going to be immutable types of objects. Most commonly they're going to be strings, but we can take advantage of this built-in counter class in the collections module to perform the work that we showed you in the preceding script in that loop. So it's going to do all of that work for us. Now, to demonstrate this concept, let's switch over to the terminal window here, and let's go ahead and from that collections module, let's import the counter class. And just to demonstrate, by the way, we're going to take a string. I've pasted in the same text statement that we created in the script. So we're going to once again have this string, or actually two strings that are going to be assembled together into one string. And remember, what we did in the script is we told that string to split itself into a list of individual strings. So just to show you what that does, if I say text.split, you get a list. There's the square brackets denoting a list of string values, comma delimited, of course, and these are all the individual words that you see in the text body up above here. So what we're going to do is feed text.split into the creation of a counter object, and as part of creating the object, it's automatically going to summarize all of these words into their word counts. So to do that, we're going to create an object I'll call counter, and with a lowercase c to differentiate it from the class name, and we'll say text.split here, and that's going to go create the counter object. And to save me a tiny bit of typing time here, I'm going to go ahead and put in a little for loop that's going to iterate through my new counter object's items. So it is still a dictionary, and therefore I can still call the items method on it. And the items method, of course, is going to give me back key value pairs as tuples. I'm going to take those tuples and pass them off to the sorted built-in function, which will give me those tuples in lexicographical order. These are all lowercase strings, so they will be in alphabetical order. And for each word and corresponding count, we're going to display a line of text containing the word and the count. So let's go ahead and execute that. There are all of the words and all of the counts, and if you were to go back and compare them to the output of the preceding script where we used the same text, you'll see we got the same exact results. Now, separately, we can also go ahead, like we did in the preceding script, and display the number of unique keys once again. So to do that, we're going to use the length of the counter.keys method call. So counter.keys is going to give us the actual collection of keys, which is a set of unique values, and the length of that, of course, is the number of unique keys. We can also simply take the length of the counter object itself, because it is a dictionary, and the number of key value pairs would also be the number of unique keys. So as you can see, once again, the number of unique keys is 10.